Brant, what'd you get?
I'm not sure. I was confused on what was asked.
Okay,
That was the last
N is
little bit.
1.
Okay.
If I put 1 in here, what do you get for a
One.
term?
1.
1. And the decimal for 1 is 1.
Yep.
If you put 2 in here, what do you get for a term?
Negative 1/2.
Perfect. And you would tell me that's a negative 0.5, correct?
Yep.
If you put 3 in there, what would you get?
1/3.
And you'd get 0.333. Am I right?
Yep.
Okay. If you put a 4 in there, what do you get?
Negative 1/4.
Okay. And are you okay with that's a negative 0.25?
Yep.
Without using a calculator right now. What about this one?
Just 1/5.
And you get 0.2 and 6.
Negative 1/6.
And that's going to be a negative 0.167. You trust me on that?
Sure.
Okay. It's 0.6 repeating, negative 1/6 repeating. What about this next one?
1/7.
And I forgot what 1/7 is. Point something. 0.143, I think. And the last one,
Negative 1/8.
and that's going to be a negative 0.125. That was one we had to have memorized in Kruger welding. Because you'd have 1/8 of an inch. Okay. All right, so that's just the sequence, right? It's just the terms you get, and now we're going to add them. So the sum of the first one's going to be itself. And this one's going to be S of 1 plus is going to be the sum of these two. Would you agree? What do you get? And we'll pick Ethan. So when I add these two terms, what do I get?
1/2.
1/2, which is 0.5, correct?
Yep.
Okay, now, you may need a calculator for this. You're going to take 1/2 and add 1/3.
5/6.
5/6. And what's the decimal for 5/6?
0.833.
0.833, okay? And now you're going to subtract 1/4 from 5/6.
0.5833.
I didn't hear what you had as a fraction.
Point. Don't know what's that in a fraction.
There's nothing wrong with using your calculator to come up with your answer.
Seven twelfths.
Yeah, 7/12. What do you get for a fraction?
0.5833.
All right, now you're going to add 1/5 to this. What's that going to give you as a fraction?
47/60.
47/60. Perfect. And what do you get for a decimal for that? Point something.
0.7833.
Okay, now you're going to subtract 1/6.
37/60.
37/60. And the decimal for that is,
0.6166.
can I write 7?
Yeah.
Okay, now you're going to add a 7.
319/420.
And what decimal is that?
0.7595.
Or how about 0.760? Okay, and now you're going to subtract an 8.
533.
533 over
840.
840, and the decimal is point what?
635.
Alrighty, so down here, this is going to be 1, this is gonna be 2, this is gonna be 3, 4, 5, 6, 7, 8. And then this is gonna be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. And this right here is the sum of the first term. This is sum of the first 2 terms, sum of the first 3, sum of the first 4, sum of the first 5, and so on. Right? Everybody agree with that? And what I'm going to have you do is plot them. So right here, 1 would go to 1. 2 would go to what?
0.5.
0.5. 3 would go to just above 0.8. Would you agree? Like right here. Anybody watch Caitlin Clark yesterday, last night?
I saw like their highlights.
Yeah, I watched it.
Oh, I watched the whole game.
Yeah, I do too.
I just go, I can't believe how she can shoot.
Yeah, it is crazy.
Everybody all over, and from like way, we used to call it downtown. I don't know if anybody
Yeah.
calls it.
No, we still
We still call it that.
Okay, I don't know if that was still a cool thing to say.
Oh, it is.
Maybe it's uptown now, whatever. All right, 4 would be just under 0.6. And 5 would be just under 0.8. And 6 would just be above 0.6. And 7 would be almost in between. And then 8 is a little bit more above 0.6. All right, I like that graph because we know it converges, correct? It looks like it's converging to something, correct? It does. And that it converges to is the natural log of 2, and I'm going to show you the proof. No, you're not going to have to know the proof, but I was so excited to do the proof, I did it 3 times. Yeah, not yesterday. Yesterday was Monday, on Sunday. My wife said, "You doing that proof again?" I said, "Yes, I do." So that's 0.693, approximately. And I'm going to get my little ruler out of my fancy tool holder. See, I can be careful about how I put my pencils. That one's just good by itself. So, and I'm going to draw that. And it converges right here. Here's 0.7, just underneath it. Okay, that's where it's headed to. Okay? Good visual. You understanding where that is coming from, right? Kind of explained your confusion. Now, Brant, you see this dot?
Yep.
It's a long ways from that number, isn't it?
Yeah.
Okay? We call this a mistake because it's a long ways from the real value. But what we really call it in math, my dad would call it a mistake. I would say, Dad, that was simply an error. Okay? Compared to this error. Which is little, correct? It's just a little bit of an error. Okay? So when we talk about this, there's a couple of things you need to know. First of all, we'll go back to blue. Error and remainder mean the same thing. So if you see the word remainder and you say, well, that's how far are, like when you do division and it doesn't work out perfectly, right? You don't get that 0, you get that remainder. That's really how far you are from getting being at that 0. Does that make sense? So that's kind of where it's coming from. All right. So the error is defined as the absolute difference between the real sum and the partial sum. This is the real sum. This is the partial sum. Because this tells you how many terms you're adding together, right? This is the partial sum of 8 terms. And what this is going to be is the natural log of 2 minus 1. So this error would be approximately 0.307. This would be the natural log of 2 minus a half, because a half is right here, which would be about 0.193. And I could keep doing that all the way along, which I did, because I was having such a fun time. 0.140. 0.110. 0.009. Excuse me, 0.076. 0.066. 0.059. Okay? So those are errors. Or, now, here's the cool part. This thing right here is called R sub n, which is our error. And here's the cool part. It's bounded. It cannot exceed this. It will never exceed this. The next term. Not the next sum, the next term. This is what we call our error boundary. So, right here, this was here's 1. It was less than the absolute value of a sub 2. So if you look at a sub 2, it's 0.5. The absolute value of it is 0.5. This error, that's the error that we computed, it has to be less than 0.5. This one has to be less than a sub 3, because this is the error of the first, using the first 2 terms, which was 0.93, and if I look at this, here's my third term, it's less than, sure enough, 0.93 is less than 0.33. This has to be less than the absolute value of the fourth term. The fourth term was, the absolute value of it was 0.25. Sure enough, it's less than 0.25. It doesn't mean it's going to be real close to that, it just can't be beyond that. So if I know what the next term is, I know that my sum that I have is got to have an error less than the next term. I'll say that again. The sum that I have, the partial sum that I've computed, has to be less than the next term. So if you take a look at this, this is going to be less than, we'll have an error less than 1/9, 0.111. It has to be less than that. Well, if you take the natural log minus this value, so if you take 0.693 and subtract this from it, you're definitely going to get something that's less than 0.1. 1, correct? All right, so you have some terms here. S is the sum of the series, S sub n is the partial sum. The remainder is the remainder or error. This is how you compute it. And n is the next term, or what we call the error bound. I'm going to write next term right here also. Okay, flip it over. So these questions are always on the free response. They have been for about the last 10 years. They may be like an A, B, C, or D, okay? So it says, determine the number of terms required to approximate the sum of the series with an error less than 10 to the negative 3. All right, what do I know? I know this. Oops, don't want that. Has to be less than this, the next term. And I know the absolute value of the next term. And I know that the absolute value of the next term has to be positive, and it has to be 1 over n plus 1. And I'm going to pause there. Does everybody know why I wrote n plus 1 rather than n? So when I see this, this is the current term I'm at. So if this was a 3, my next term would be 4. Would you agree? If I'm at 15, my next term would be 16. It's going to be 1 more than that. So all I have to do is put n plus 1 into wherever I see n. Right? So I know this. Has to be less than 1 over n plus 1. And I want that less than this. Where did I get 1 over 1,000?
It's 10 to the negative 3.
That's what 10 to the negative 3 is, correct? Okay. So that means 1,000 is going to be less than n plus 1. So n has to be greater than 999 terms. Okay, done. It says determine the number of terms required to approximate that sum, the alternating harmonic sum. So I have an error of less than 1 over 1,000. I'd have to, first time that would happen is when I get to 1,000 terms. Would you agree with that? All right. Okay. If this is series is approximated by the partial sum with 10 terms, what's the alternate series bound? Okay, partial sum with 10 terms. Well, this is what? The absolute value of what?
S minus S sub n.
Say it again.
S minus S sub n.
And you're correct. That's what the error is. Okay. The bound is what? This is the error. That's bounded, and over here is the error bound.
Is that the A of n plus 1?
Absolute value of A. Okay? So this is S. This is S minus 10. Correct? Because it says partial sum with 10 terms. This has to be what term?
S sub 11.
Correct? This is my term. So what's this gonna be? 1/1.
57.
So, the sum of the first 10 terms has an error less than 1/57 from S. So you're pretty close. Doing okay? Matthew, look a little sleepy. Okay, this one's calculator active. Does everybody know how to do this in your calculator? Okay, so what I want you to do is put this in your calculator and tell me what S of 5 is. Yes, ma'am.
Can you show me how?
And you have a TI? I don't have a new TI.
Now I have a TI 4 plus.
I think you go to math, what is it, math at the very bottom.
Yeah, it doesn't pop up, but it's there. Oh,
I think you can scroll to get there, can't you?
okay. Oh.
Yeah, you can.
I think you
I
was-
don't know how to do it either, but I'm on a TI 83.
Yeah, I thought I did, we figured it out how to do on a TI 83.
Yeah, there's like a lot of steps, so I don't remember.
You gotta be able to do it, I don't know if I have my TI 83 here, we figured it out.
Wait, it's just under 5 terms, so we just go 5. We go from X equals 1 to 5.
The ends.
Well, whatever.
Yeah, because you don't have it on a TI 83 plus. You gotta do it a different way.
That's like when we had to do the really weird like sum.
Yeah,
and
you
in
still got,
parentheses is like
right.
something else. It was like sequence then. I don't know.
Yeah, so you find sum, if you go to second,
Stop it. Hey, what'd you get? The
yeah,
second,
if you
second
go,
list.
if you go to second list and go to OPS,
Did you just say a fraction?
Yeah, I'll put in
Yeah.
3.3.
and that's where you can get your sum.
That's
Thank you.
my sum is in my math.
Okay, go to your math, yeah, that's where it is. So you go to sum, and then I think you gotta go there to get the sequence, don't you?
Yeah.
Where is it in math?
No, you have to go second list and then inside list there's math.
If you broke, just say that.
Alright. And then so you get the sum and then inside the sum you put the sequence.
Where's the sequence?
It's in OPS.
Okay. Oh yeah, it's line 5.
Mm-hmm.
And then I think you put that in there, don't you?
Yeah, I can try that.
So, I'll work on that when I'm done with this lecture. I don't wanna spend a lot of time doing that. What did you get for an answer?
3.354.
Okay, you guys got that too?
Yeah.
Okay, so now notice it says an approximate interval. Okay, you want an interval here now. So what you're going to do is you're gonna find your error bound. And so your error bound is going to be what? the absolute value of what?
A of 6.
A of 6. Because this is the first 5 terms, correct?
Yeah.
So when I put 6 into there, I'm going to have 4 over 6 squared. Would you agree? Everybody agree with that?
Mm-hmm.
Which is 1/9. So that means the absolute value of the true sum minus S of 5 is less than or equal to the absolute value of 1/9. Would you agree with that?
Yeah, that makes sense.
Okay, that makes sense so far? Okay, so that means S minus S of 5 is less than or equal to 1/9. And over here it's bounded by a negative 1/9. Because you know it was going up and above and below, right, on that picture? Here I'm above, next time I'm below, here I'm above, here below. You're alternating back and forth from that limit. You doing okay with that? So that's why I put positive on this side and negative on that side. So now I know I've got S minus 3.354. Where did I get that from? Brandt. This is less than or equal to, I'll go 0.111. That's what the 3 decimals for 1/9 are. Over here I'm going to have a negative 0.111. And so my true number, the true sum, has got to be within this interval. 3.465. How did I get that? I just added 1, 1, 1 to this. And on this side I'm going to subtract it, so it's going to get 3.243. So the true sum's got to be somewhere in between these two numbers. So again, what did I do? I figured out, you guys figured out on your calculators the sum of the first 5. I say, hey, it's bounded by this. And so I come to here, I need to know this. I create an interval, and then I just do some algebra. All right, so let's take a look at this one. Every time I saw these when I was in college, they scared me. And then Dr. Tom said, Chuck, it says f of 1. Just put 1 in here. And I said, okay, I can do that. I can put a 1 in here. And when I put a 1 in here, n equals 0 to infinity, I'm going to get 1 to the 2n power. Well, that's just going to be 1, correct? And down here I have 2n plus 1 factorial. Well, it says, show, and if you notice, well, I'm going to do something here. I'm going to say, all right, n equals 0. Why did I choose 0? Because it's starting at 0. When I put 0 in here, I get 1 on top, and I get 2 times 0, which is 0, plus 1, which is 1, factorial, which is 1. So a sub 1 equals 1. Sure enough, I got a 1 right here. And this is going to become, when I put this 1 in here, it's going to be 1 minus a third factorial, excuse me, not a third, 1 over 3 factorial plus 1 over 5 factorial minus 1 over 7 factorial, right? Plus dot, dot, dot. Are you okay where I got the 1? I'm just putting 1 in for x. And when I go in here and put 1 into here, I'm going to have a negative 1 over, now if I put a 1 in here, I get 2 times 1, which is 2, plus 1, which is 3, I get 3 factorial. Ha! That's what I have right there, don't I? So that means my true sum minus S of 2. Why did I choose 2? I got these 2 terms right here. one right here was a sub 2. Has to be less than or equal to the absolute value of what?
It's like a sub n plus 1.
Which is
A sub.
a sub what?
What
Should
are
be
we
your
on it?
favorite number by now.
A sub 3.
Yeah, you can't get it wrong. Right, because I'm already doing these first two terms. Does that make sense, Walker?
Yeah, I didn't know what number we were.
Okay, so that means I'm going to have less than or equal to. Now I'm going to put a 3 into here. And if I put a 3 into here, I'm going to get a, what do I get when I put a 3 in there? Boom, my next term is n equals 2. So that's my third term. So I'm going to get a 1 over 2 times 2, right? Because that's an n. 2 times 2 is 4. 4 plus 1 is 5. It's 1 over 5 factorial. Well, that's positive. All right. 1 times 2 times 3, 6 times 4 is 24, times 5 is what? What's 24 times 5? 1 something I heard. 120. Okay? Would everybody agree?
Yeah.
Right? Everybody agree with that? 24. You guys are looking at me like you're not sure. Okay? It's 120. Okay? Now, what's nice about 1 over 120? It says, show that this approximates this value with an error less than 0.01.
Well, that's less than 0.01.
Yeah, it's less, oops, it's less than 0.01, right? Now it says, show that this number has an error. Did I show that? Yeah, I said, okay. I said, all right, I put my 1 in there. I know I'm looking at these first two terms. Here's my next term, my third term. It's 1 over 120, and that's less than 1 over 100. Bingo, I showed it. And then, to make me feel good, I'm going to write QED. Irish Spring. Okay. And that's it. Now, I'm going to show you one more thing, okay? I did this proof 3 times. I'm going to make you look at it. You do not need to have it memorized.